Hello, everyone. My name is Michael. I am a current junior majoring in computer science and economics. Today, we'll be covering one of my favorite topics in EECS203, the Pigeon Hold Principle. So what is the Pigeon Hold Principle? Let's think about this case of scenario. Say you have a flock of pigeons flying home, flying back to their pigeonhole to roost. Now, if you have, say, more pigeon than pigeonholes, say if you have 9 pigeons, but only 8 pigeonholes, what would this mean? Well, this means at least one pigeonhole will have more than one pigeon in it, because there's no way that you can arrange it to have one pigeonhole that has less than one pigeon in it. Because say if you have one pigeon each for the first 7 holes, for the last hole you must have 2 pigeons in it, otherwise it doesn't add up to 9. So how can we take this a step further and make it a theorem? This means that for k plus 1 objects to place into k boxes, there must be at least one box that contains 2 or more objects. This is the first theorem. Let's think of an example. So in a group of 367 people, what would this mean? This means at least 2 people will have the same birthday, because there's only 366 available birthdays. And the last person, and after the first 360, and after the 366 person takes up all of the unique birthdays, the last person must be on the same birthday as the former 366. Another example would be with English words. If we have 27 English words, this means at least 2 words must start with the same letter, because there's only 26 letters in the English alphabet. Say if A, B, C, D, E, F, G, all those words are taken by the first 26 words, and there's no conflict, then the 27th word must be having a conflict with one of the 26, because otherwise that word will not be English, because there's only 26 options and there's 27 people choosing the options. So one option must be chosen by 2 people. You can kind of think about it like that. So let's take it a step further and not limit ourselves to more than one. Say if you have n objects placed into k boxes, then we can kind of deduce some similar theorems. Then this means at least one box will contain n divided by k to the upper objects. This is kind of like the second theorem in the Pigeon Hold Principle, called generalized Pigeon Hold Principle. Say if we have 100 people, this means at least 9 people will be born on the same month, because what you can do is you can divide it by 100 divided by 12, that gives you 8 point something, and then you upper it, that gets you 9. Logically, if you think about it, say if we want to prove by disproof, how do we do that? We assume that for the first 11 months, we don't violate this. We don't let this to be true. So for the first 11 months, let's say each month has 8 people in it. So we have 8 for January, February, March, so on, all of it, we're in until November. How many people would that be? That would be 88 people, right? Well, then how many people must be in December? 12, because otherwise you can't add up to 100. Well, this kind of contradicts with our initial goal, because we already have more than 9 people born in the same month. So this kind of goes to show how Pigeon Hold Principle is kind of always true. Now, here's a brain teaser. How many students in a class must there be to ensure at least 6 students gets the same grade? So we know that the grade options are A, B, C, D, and F. We're not going to talk about E. So let's say there's 5 types of grade. How many students must there be in the class to ensure at least 6 students get the same grade? Well, we can apply that math equation. We know that there's 5 possible grades, so there's 5 boxes. And we don't know how many students there are, but we know that we want to ensure at least 6 students get the same grade. So it's kind of like n divided by 5 to the upper equals to 6. Well, what is going to be n in this case? We know that n cannot be less than 25, because if n is 25 or less, then we wouldn't result to a 6. So we know that n must be more than 25. What is the closest number that gets us more than 25? That's right, 26. So we know that at least 26 students must be in the class for this statement to be true. Well, this is it for Pigeon Hold Principle. If you enjoy it, please do more practice. This is going to be on the test. I'm 100% sure because I've taken it. So yeah, I hope you enjoy it, and thank you so much for your time. Have a great day.